the transmission. So the next topic is comparison of conductor material in overhead system. So now we will know about the volume of conductor material for each system. So first system is a two-wire DC system with conductor earthed. So this is a DC system. This is the current I1. This is voltage, and this is a system earthed. Okay, so let's consider maximum voltage supplying to the system is Vm. Then power will be P. So the load current I1 will be P by Vmax. We know P is equals to voltage into current. So your current will be power by voltage. So P by Vmax. Now your resistance required by the system is rho L by A, where rho is a resistivity, R is resistance of each line conductor, and A is cross-sectional area of that conductor. So your resistance is rho L by A1. For two-wire system, let's consider cross-sectional areas A1. So your now line losses in every system there is a line loss. So we represent line loss by omega, which is 2I square R, in which I is 1, I1. For two-wire system, we consider current as I1. So 2 I1 square R. So let's put value of I1 and R in this equation. Then it will be omega is equal to 2 P by V max the whole square rho L by A1. Okay, so volume required for two-wire DC system will be now twice of cross-sectional area into length, right? So volume is what? Area into length. So twice of cross-sectional area into length. So just rewrite the equation. Then we will get area. After rewriting this equation, we will get area. Just cross multiply this, take this area this side and omega this side. We will get an equation, this equation as 2 P square rho L omega Vm. Okay, so we have got A1, that is a cross-sectional area. Put that cross-sectional area in this equation. Let's consider this equation 1. Put this in equation 1. We will get 2 bracket 2 P square rho L omega M into L. So just multiply this 2 inside and this L also inside. Then we will get V is equal to 4 P square rho L square omega M. So this is the volume of a two-wire DC system with 1 point earthed. And let's consider this equation as K. This we will take as V1 for DC system, two-wire DC system. Let's consider this as V1, and we will denote it by K. And the equation is 4 P square rho L square omega Vn, where P is power, rho is resistivity, L is length of the wire, omega is losses, and Vm is the voltage across the system, maximum voltage across the system. Then we will get the volume of a two-wire DC system. Moving further, we will now learn two-wire DC system with midpoint earthed. Okay, so this is the diagram for a system, two-wire DC system. This is a diagram of two-wire DC system with midpoint earthed. Okay, so midpoint is earthed, and then the voltage around each system will be Vm. For this system will be Vm, and then the total voltage, maximum voltage flowing through the system will be 2 of Vm, that is twice of Vm. And then power we will consider as P. So the load current flowing through the system is P upon 2 Vm. And then resistance of this system will be rho L by A, where rho is a resistivity, L is length, and A is cross-sectional area. We will consider A2 as a cross-sectional area for two-wire DC system with midpoint earthed. So the line losses will be 2 I2 square R. So just put the value of I2 and R in this. We will get P upon 2 Vm, where Vm is a maximum voltage. You can see here. Yes, right? Vm is a maximum voltage, but here it is twice of Vm. So we have put here twice of Vm, the whole square, rho L by A square, where rho is resistivity, L is length of conductor, and A is cross-sectional area. So rearranging this equation, we will get cross-sectional area of the system, which is P square twice of Vm square. Sorry, this is 4 Vm the whole square into rho L by omega, where rho is resistivity, L is length, and omega is losses of the system, right? So the volume required is 2A2 into L, where twice of cross-sectional area into length, which is our volume, right? So volume, let's consider this as equation number 1. So just put all the values in this equation. We have to put cross-sectional area in this equation. We will get twice of P square 2 Vm square rho L by omega into L. So now we can just simplify this equation by eliminating this 2 and this 2, as this 2 is in numerator and this 2 is in denominator, which can be eliminated. So the final equation V for V2. So this is V2 P2 rho L by Vm square omega. As we know that for two-wire DC system, we have considered 4. You can see we have consider this as 4 P square rho L by omega m square. So your substituting this P square rho L square omega m and transferring this 4 to this side, we will get this equation as K by 4. So your V2 volume for a 2-wire DC system with midpoint earthed, we will get as K by 4, right? So moving further is a 3-wire DC system. So 3-wire DC system, we can say this is one system, this is another, and these are 3-wire 1, 2, and 3. So for 3-wire DC system, your maximum voltage will be twice of Vm, right? So your current flowing through the system will be P by twice of Vm. P is a power and V is maximum voltage flowing through the system, and your resistance will be rho L by A3, where rho is a resistivity, L is the length of conductor, and A3 is the cross-sectional area for 3-wire system. So your line losses omega will be twice of I cube whole square into R. So this is line losses. So what are line losses? So line losses are the losses in the transmission line which occurs while transmitting, as when voltage is transmitted, it will generate some magnetic flux, and that flux we consider as a losses, and we consider this loss as a copper loss. So the material used is a copper, so we consider is a copper loss, that is twice of I square R. So line losses omega, we denote it by omega, is twice of I square R for 3-wire system. So putting the value of current and resistance, we will get P2 Vm the whole square. So resistance will be rho L by A. A is a cross-sectional area of that system or conductor, we can say. So rewriting this equation, we will get A3 as 2 P square upon 4 Vm the whole square rho L by A. Rewriting this equation, we will get this as 2 1 2 twice. So this equation will become P square twice of Vm square rho L by omega. So volume of a conductor material will be 2.5 A3 into length, area cross sectional area into length. Now why we have not taken here 3 instead of taken 2.5? Because assuming the cross-sectional area of neutral wire to be the half of the outer wire. So the cross-sectional area of this neutral wire will be half the times of the outer wires. So that's the reason why we have considered this as 2.5 and not 3 for a 3-wire system, right? That's all for today. In next lecture, we are going to learn about the conductor material for single phase and 3-phase AC system. Thank you.